right, this is Unit 5, Lesson 4, practice problem number 15. So for this one, we have a triangle ACD, right, the bigger triangle here, and it tells us in the problem that's isosceles, and they've got AC marked congruent to AD. So what's important to know about isosceles triangles, right, is that if two sides are congruent, that means that their base angles are also going to be congruent. So I know that whatever angle D, this whole angle D right here is, it's going to be the same as this whole angle C over here. But then we also have another triangle BCD, and this triangle BCD, they also tell us in the problem is isosceles, and they've got BC marked congruent to BD. So again, because this one is an isosceles triangle, I know that whatever this angle BDC is, right, whatever that angle is going to be congruent to this angle BCD, because those are the base angles there. Well, then they also give us some measurements that we can put in. But before we start putting the measurements in, I would also like to point out to you that we do have two congruent triangles here based on the side postulate for triangle congruence. Triangle ABD and triangle ABC have to be congruent to each other. We know that AD is congruent to AC, and we know BD is congruent to BC. And then the two triangles share this side AB. So using the reflexive property, right, it's got to be congruent to itself. So we have a side proof to say that these two triangles are the same. Now that's important because now I know that if I can figure out what this angle ADB is, it's going to have to be the same as this angle ACB. But also, if I can figure out what this angle ABD is, it's going to be congruent to the angle B in this triangle, angle ABC. And likewise up here, centered around angle A, angle BAD is going to have to be congruent to angle BAC. Okay, so knowing that these triangles are congruent gives me a lot of pairs of angles that also have to be congruent. Okay, so then the angle measures that they give us, they tell us that angle DBC, angle DBC is 110 degrees. So DBC, it's this angle right here, is 110 degrees. Now, just using that, if I look at my triangle BCD, right, my isosceles triangle down here, I only have one of those angle measures, but I know that the other two, the base angles, have to be the same. So I'm going to do 180 minus 110. That's going to leave me with 70 degrees. And I know that 70 degrees has to be split evenly between the two base angles in this triangle. So now I'm going to do 70 degrees divided by 2, and that's going to give me 35 degrees. So now I know that this angle is 35 degrees, and I know that this angle is also 35 degrees. Okay, but then they also told me that angle BDA was 22 degrees. So angle BDA, so BDA is over here. Well, if this angle is 22 degrees, then this angle over here, BCA, also has to be 22 degrees, right? Because these two triangles were congruent to each other. So now I actually have enough information that I should be able to find any other angle in this figure. Because if I go back to looking at my big triangle here, triangle ACD, we're looking for the measure of angle BAC, right? So this is the angle that we're trying to find. But I have enough information right now to find this whole angle, right? If I look at my big triangle ACD, I know that the whole angle D, ADC, right, the whole angle here, 22 plus 35 is going to give me 57 degrees for that whole angle. Well, over here on angle C, if I do the exact same thing, 22 plus 35 is going to give me 57 degrees for the measure of that whole angle. If I subtract 57 and 57 from 180, that's going to give me the measure of angle A. So I'm going to do 180 minus 57 minus 57. Oh, that's 180 minus, what, 114? Okay, that gives me 66 degrees. Okay, so that 66 degrees, is the measure of this whole angle A, angle DAC. The whole thing here is 66 degrees. Now, if I know that these two triangles, ABD and ABC, are congruent to each other, right? That means that these two angles centered around angle A have to be the same as each other. Well, if the whole thing here is 66 degrees, we've got 66 degrees to split evenly between these two angles. So now I'm going to do 66 divided by 2, and I'm going to get 33 degrees for the measure of angle BAC.